Fine, so here we have the exercise 3.5 from the IBID textbook as part of one of the exercises that you need to do. So the first one here, we have the specific latent heat of fusion of ice is the heat required to. So this is straight from your definition, so the latent heat of fusion. Now, you've got to be a little bit careful because this is of ice. These would B and C would maybe you would think are the same, because 1 decimeter cubed of H2O of water, if it's pure water, has got a mass of 1 kilogram. But this is talking about ice, and we know that ice and water don't have the same density, and therefore 1 decimeter cubed of ice wouldn't be 1 kilogram. So C is the correct answer, to change 1 kilogram of ice at 0 degrees Celsius to water at 0 degrees Celsius. That is your latent heat of fusion. 2. A substance changes from liquid to gas at normal boiling temperature. What changes, if any, occurs in the average kinetic energy and the average potential energy? Now, I think we have to assume here that we are dealing just at the boiling point. So, in other words, temperature is constant. And so, because temperature is constant, your kinetic energy is going to be constant. But your potential energy, because you breaking of those bonds and those molecules are moving further away, so you've got your bonds, those are being broken and the molecules are being separated, the potential energy is going to increase. So we would have a constant and an increase in your average potential energy. So going down to 3. Thermal energy is transferred to a mass of water in 4 steps. Which of the following 4 steps requires the most thermal energy? Now, it's important to realize that all of these, there's a change in temperature of 15 Kelvin or 15 degrees Celsius, depending on which scale you're working on. So in each of these, the thermal energy transferred is actually the same. But in D, it's a bit more complicated, because in actual fact is going from your H2O is going from 95 to 100, and so your change in temperature is equal to 5 degrees Kelvin. You then it's going to need to boil. So at 100 degrees Celsius or 100 degree 2373 Kelvin, it will boil. So you're going to have to need to supply that vaporization latent heat. So you're going to need to supply latent heat there to break those bonds. And then further, you're going to have the H2O vapor will go from 100 to 101. It will be a change in temperature of 1 degree Celsius. So it's quite complicated. So in actual fact, this is more likely going to be the one where you're going to get most thermal energy is transferred. Okay, good.